Hello students, welcome to my channel Agriculture in Online. So, let us solve a problem from GATE 2006, question number 38 from Farm Machinery and Power. The question says reciprocating masses of an engine weigh 6.67 Newton and 60% of their weight balanced a TDC by mass attached opposite to the crank pin at radius of 7.62 centimeter. The ratio of crank length to connecting rod length is 1:4. If the engine is operating at 3000 rpm, the inertia force left unbalanced at the TDC position will be dash. So, 4 options are given. Let us quickly go to the solution part. First of all, so it is a reciprocating mass, or you can say in the engine. So, for example, this is an engine and this is a piston, you can say this one is a piston and connecting rod, let it this one connecting rod has a length of L and the radius, crank radius is R, let it be. So, L is to R ratio is given, or in this case R is to L ratio is given 1/4, or you can say R L by R will be equal to 4, or in this case N, let it be the ratio between the connecting rod and crank radius. So, the reciprocating masses, because this is the reciprocating the piston, the mass at the piston, which is the reciprocating part, actually the connecting rod, some portion mass of the connecting rod goes to the piston and some of the goes to the crank pin. Let us see the crank pin in this case. So, this is the crank pin and let it the point TDC to BDC it moves. So, TDC is the top position and BDC is the bottom dead center, you can say. So, first of all the mass of the reciprocating mass, or M, is let it be it is given 6.67 Newton, or we can say the weight will be 6.67. So, mass will be divided 9.81 is the kg, you can say. So, weight can be converted into mass first of all, and the next one is the mass of that one is since it is reciprocating mass, there will be unbalanced force at crank pin. Therefore, that sum of the mass is actually balanced. In this case, it is saying that mass, let it, this is the center and this is the just opposite to that crank radius. So, mass is actually balanced. So, and that due to that mass balance, actually 60% of the mass, 60% of mass is balanced. So, that means left mass, or you can say reciprocating mass unbalanced, will be equal to, let it 6.67 divided by 9.81 into 0.4. Since this is the unbalanced mass, you can say unbalanced mass, or MR, you can say, that is kg. Now, we know the crank radius R is given, that is 7.62 centimeter in this case, that will be equal to 0.0762 meter. So, it is easier to convert them, and also the rotation speed will be N is given, that is 3000 rpm. So, you can convert into the angular speed, that is omega, is equal to 2 pi n by 60 radian per second. So, that will be equal to 2 pi into n is 3000 divided by 60, that will be equal to around 314 radian per second. So, this is the angular speed. So, now we know that due to the reciprocating mass, what is the acceleration. So, acceleration due to reciprocating mass will be equal to, we know that omega square r, that is cos theta plus cos 2 theta divided by n. So, where n is the ratio between the connecting rod and crank radius, and this is the acceleration of the reciprocating mass. So, coming to this theta is the angle made by the crank pin with the line of the there is straight line between the crank center and the piston connecting rod, you can say. So this is the line. So theta is the angle between coming. It is from the, this is 0 degree and this is theta. So this is theta is the angle at any point of time. The acceleration will be equal to omega square r cos theta plus cos theta to 2 theta by n. This is called the primary unbalanced force, and this is the secondary, you can say. Cos theta, that means omega square r cos theta is the primary, and in the harmonic, you can say series, this is cos 2 theta by n, this is the secondary. So these forces can be balanced by this mass at the opposite of the crank radius. So crank radius is given, so therefore this is alpha. So in this case, the unbalanced force due to the unbalanced mass, so therefore unbalanced force is asked, that is the inertia force, you can say, due to inertia. So will be equal to mr. So here you can say this force, whatever, m r omega square. So at any point of time, so c, whatever the mass will be there, so that is r omega square will be the centrifugal force or inertia force, you can say. So therefore here actually the unbalanced force, or Fu, is equal to mr, that is mass into acceleration, that is alpha, or omega square r cos theta plus cos 2 theta by n. So by putting everything into perspective, so it is asked to find out the force at TDC. So if you see at TDC, the boundary condition, the theta is equal to 0. So because it is starting from this one, so at TDC theta is equal to 0. So putting this into value together, mr is already calculated and omega also calculated. So everything you put, so then 6.67 divided by 9.81 into 0.4. This is the left unbalanced force. Mass into omega is 314 radian per second, 314 square, into r is given, that is 0.0762, and coming to this cos theta is 0, cos 0 is 1 plus cos 2 theta, because again cos 0 is 1, so 1 by n is equal to 4 in this case, because already we have taken the series, n is equal to 4. So therefore this is the answer to solve. So therefore the unbalanced force, or Fu, will be equal to, that is 2554.12 Newton. So this is stated in Newton, because this is because the kg into mass acceleration is mass into acceleration, it will be Newton. Therefore the unbalanced force left at this reciprocating mass due to this reciprocating mass in the crank connecting rod at the crank pin will be equal to 2554.12 Newton. So this is the answer for this question. I think there is option, that is B. So therefore the answer will be B. So hope you understand. Please like and subscribe to my channel.